Imagine standing at the base of a structure so immense, so perfectly aligned, that it defies your every assumption about human history. We're talking about the world's true megastructures, buildings constructed thousands of years ago, using technologies we believe didn't even exist yet. Structures so advanced, so complex that modern architects and engineers, equipped with powerful cranes, laser guidance, and computer modeling, still can't fully replicate them today. How did they do it? Look at the Temple of Jupiter at Baalbek in modern-day Lebanon. Here, you find the trilithon, 3 colossal foundation stones, each weighing over 800 tons. That's heavier than a fully loaded jumbo jet. How were these quarried, moved across uneven terrain, and raised into place with such immaculate precision? Our most powerful conventional cranes struggle to lift a third of that weight. Now, travel across the Atlantic to the Andean mountains of Peru, to Sacsayhuaman. Here, massive stones, some towering over 20 feet tall, are cut into complex, irregular polygonal shapes and fitted together without any mortar. The fit is so tight, you cannot slide a piece of paper between the seams. This isn't just incredible stonework, it's a structural design that has allowed these walls to survive centuries of devastating earthquakes. They are, quite literally, earthquake-proof. And of course, there are the Great Pyramids of Giza. $2.3 million blocks of stone, perfectly oriented to true north, built with astronomical and mathematical precision that still challenges scholars. The sheer volume and speed of construction required for this project baffle us. The logistics are mind-boggling, even if we accept the simplest ramp theories. These aren't anomalies. They are monuments to an engineering genius that has been utterly forgotten. It's as if ancient civilizations possessed a secret handbook on construction, a guide to defying physics, manipulating materials, and conquering scale, which was simply lost to the sands of time. This forces us to ask the core question of this journey. How did ancient civilizations achieve feats that challenge modern engineering, even with our advanced tools? They say time reveals all truths, but some structures still hold their secrets tight. We're talking about buildings that defy physics, engineering principles, and even our understanding of what was possible in the past. Get ready to explore the impossible constructions that force us to question everything we thought we knew about history. We're going on a journey to uncover the engineering genius behind structures that modern technology struggles to explain. Join us as we decode the impossible and confront the sheer ingenuity of civilizations long past. You won't look at ancient ruins the same way again. In part 1, we established the mystery. Now let's peel back the layers and examine the evidence of genius that still baffles the scientific community. When we talk about impossible structures, we are focusing on 2 key elements: precision and scale. Our first stop is the ancient Roman outpost of Baalbek, Lebanon. While the Romans certainly built the impressive Temple of Jupiter, the mystery lies beneath it, in the massive foundation known as the trilithon. We have 3 cut stones here set into a retaining wall, each a geological anomaly. They are roughly 65 feet long, 14 feet high, and 12 feet wide. Based on their density, each stone weighs approximately 800 to 1,000 tons. To put that into perspective, the largest object moved by any early modern civilization was generally in the range of 10 to 50 tons. Moving these Baalbek stones would require dozens of modern industrial cranes working simultaneously. In fact, if you tried to lift one of these stones today using conventional methods, you'd likely need equipment far larger and more specialized than anything found on a standard construction site. The puzzle isn't just the lifting, it's the movement. These stones were quarried miles away, and researchers cannot find any geological evidence of a viable path, road, or ramp capable of sustaining such immense, concentrated weight. Furthermore, they were not just dropped into place. They are perfectly aligned next to each other, forming a seamless, load-bearing foundation. This suggests a level of planning, resource allocation, and crucially, technology that simply doesn't fit the historical timeline we've been taught. Now let's shift continents to Peru and the incredible citadel of Sacsayhuaman. This site is the ultimate testament to precision stonework. The Incas who built this structure mastered a technique known as polygonal masonry. Instead of cutting uniform rectangular blocks and cementing them together, the builders used stones of wildly irregular shapes, some with 12 or more angles, and fitted them like a massive three-dimensional jigsaw puzzle. Crucially, they did this without the use of mortar. The joints are so meticulously crafted that, again, not even a human hair can slip between them. Why this extreme precision? Because these are seismic zones. When an earthquake hits, a rigid mortared wall shatters. But the walls of Sacsayhuaman, with their interlocking non-uniform joints, act as natural shock absorbers. They shift, settle, and then lock back into place, distributing the enormous energy of the tremor. For over 500 years, these walls have withstood seismic activity that has decimated modern construction built just down the road. This is not simple stone cutting. This is highly sophisticated, load-bearing, and seismically engineered architecture. It required an understanding of angles, mass distribution, and geological forces that we only formalized in the 20th century. To achieve this level of perfection using only bronze tools and human power is an enigma wrapped in solid rock. Finally, let's return to the Great Pyramid of Giza, the ultimate measure of scale. 2.3 million stone blocks, a construction project that would put modern infrastructure programs to shame. But beyond the sheer volume, it's the precision that is truly mind-bending. The base of the Great Pyramid is nearly perfectly level, with less than an inch of variation across its 13-acre footprint. The four sides are aligned almost exactly to the cardinal points of the compass, true north, south, east, and west, with a margin of error that is almost negligible. How did they achieve this kind of orientation without satellites or modern navigational equipment? Furthermore, mathematical constants seem to be deliberately integrated into its design. The ratio of the perimeter of the base to twice its height provides an astonishingly accurate approximation of pi, the mathematical constant that defines the ratio of a circle's circumference to its diameter. It's difficult to argue that these ratios and others relating to the golden ratio are merely coincidental. The foundations of the pyramid are a paradox. An ancient civilization, without any advanced instruments we know of, achieved a level of geometric and structural precision that remains a benchmark for construction today. These sites, Baalbek, Sacsayhuaman, and Giza, force us to confront a clear pattern. Ancient civilizations possessed an operational knowledge of large-scale engineering, seismology, and geometry that was far beyond the scope of their presumed technology. The foundations they laid are colossal, precise, and utterly defiant of the time in which they were created. But the question remains, what was the source of this forgotten genius? We've seen the monumental scale and the impossible precision. But the ultimate barrier to understanding these structures is the logistics. How do you go from a raw quarry, miles or even hundreds of miles away, to a finished temple wall? This is where the engineering genius truly shines, or where the theories truly fall apart. Let's return to the Great Pyramid. Forget for a moment the precision, and focus just on the volume. $2.3 million blocks. Conventional archaeology suggests this was done over a period of about 20 years. Simple division tells us that to complete the pyramid on schedule, a new $2.5-ton stone block had to be quarried, transported, and set into place every 2 to 3 minutes of every working day, non-stop, for 2 decades. This is a supply chain and efficiency challenge that would cripple a modern construction firm. And the most contentious part of the puzzle is the verticality. How did they get the blocks to the top? The most accepted hypothesis involves building enormous, spiraling ramps made of compacted earth and rubble. But to reach the pyramid's original height of 481 feet, a ramp built at a safe gradient would have to be over a mile long, containing more volume than the pyramid itself. The effort required to build, maintain, and then dismantle these colossal ramps rivals the effort of building the pyramid itself. Some engineers have proposed internal ramps, spiraling up inside the structure, which is a fascinating but equally complex theory that still lacks definitive, large-scale evidence. The logistics of lifting these immense weights, day after day, year after year, remains the Great Pyramid's most enduring and perhaps most humbling paradox. The challenge is different when the distance is the problem. Consider Stonehenge. The huge sarsen stones are local, but the smaller, distinct blue stones, some weighing up to 5 tons, were transported from the Preseli Hills in Wales, a journey of over 103 miles. How? Were they dragged across land on crude sledges and rollers? That would require immense deforestation and a staggering number of people just to cross relatively flat ground. Or were they floated along the coast and up rivers? That presents an equally immense logistical hurdle of loading and unloading fragile boats with 5-ton cargo. Whatever the method, it required organizational genius, meticulous planning, and the commitment of a massive labor force spanning multiple generations. A similar baffling feat took place on Easter Island, Rapa Nui, with the legendary Moai statues. These monolithic figures were carved in the Rano Raraku quarry and then moved several miles to their ceremonial platforms, Ahu. The largest moved Moai weighs over 80 tons. While recent experiments have proven that the statues could theoretically be walked upright using ropes and swaying motions, a magnificent example of human ingenuity solving a mechanical problem, the sheer effort required and the consistency across the entire island speaks volumes about the collective focus and engineering prowess of a relatively small, isolated society. It wasn't just physical labor, it was applied physics. Perhaps the most bewildering example of logistical genius combined with impossible precision is found high in the Andes, Puma Punku. The stones here are smaller than Baalbeks, but they are infinitely more complex. We find hundreds of modular blocks, many featuring incredibly sharp, standardized H-cuts and precise notches. These are not just rough-cut stones, they are components built to be universally interchangeable, fitted together like sophisticated Lego blocks or prefabricated components. The engineering questions here are manifold. First, the material. The red sandstone and andesite stones were quarried some $10 to $50 miles away. Again, the movement of $100-ton slabs across the Andean Altiplano, an incredibly high and harsh environment, is a feat of logistics we can barely imagine. Second, the cutting. The precision of the H-blocks is so fine, featuring sharp inner corners and consistent angles, that replicating them today requires specialized diamond-tipped rotating tools. The ancient builders achieved this perfect geometry and mass standardization without any known iron tools. This suggests a mastery of abrasion, measurement, and template construction that truly pushes the limits of our understanding of their available technology. From the 2-minute cycle of Giza to the $140 mile haul for Stonehenge's bluestones, and the modular genius of Puma Punku, the transport and assembly of these structures reveals a mastery of applied science, organization, and workforce management that is, quite frankly, astonishing. But if these ancient cultures were so brilliant, why did this knowledge seemingly vanish? We have established the facts: the massive stones of Baalbek, the seismic precision of Sacsayhuaman, and the baffling logistical demands of Giza and Puma Punku. Now, we must confront the logical next step. If we can't fully explain it with the known history of technology, then what is the explanation? The hypotheses generally fall into 2 broad, often conflicting camps. Either these cultures possessed a form of lost technological knowledge, or the complexity is purely a product of forgotten human ingenuity, a mastery of organizing immense manpower. Let's first explore the theories that suggest a greater, more sophisticated understanding of physics or mechanics than we give ancient people credit for. Perhaps there was a highly advanced civilization, maybe pre-dynastic Egyptians, maybe the builders of the Indus Valley, or even the mythical Atlantis, who possessed a form of advanced science that was wiped out by a global catastrophe. One of the most radical yet persistent ideas revolves around the use of sound or resonant frequency. This theory posits that the ancients could generate specific frequencies or powerful sound waves to temporarily negate gravity, allowing massive stone blocks to be lifted or moved with minimal physical effort. While this sounds like science fiction, modern research has shown that objects can be levitated using complex acoustic waves. Could the ancients have stumbled upon or mastered this principle? Another idea centers on geopolymer cement. The theory suggests that many of the Giza blocks weren't natural stone at all, but a sophisticated form of limestone concrete or geopolymer molded directly at the construction site. This would solve the monumental transport problem, but it requires the ancients to have possessed an advanced chemical engineering capability, a lost recipe for synthetic stone. A less radical but equally fascinating theory suggests the ancients weren't alien-level technologically advanced, but rather possessed a profound, intimate knowledge of the Earth and cosmos that we have since discarded. Consider the astronomical alignments. The Giza pyramids align with the cardinal points almost perfectly, and some theorize their layout matches the stars of the Orion constellation, a celestial marker considered sacred to the Egyptians. How did they achieve this level of alignment without modern star mapping tools? It implies a sustained, meticulous program of celestial observation spanning centuries. Furthermore, there's the evidence of forgotten mathematics. As we mentioned, the dimensions of the Great Pyramid seem to incorporate constants like pi and the golden ratio. This isn't just a coincidence. It reflects a deep, applied understanding of geometry and numerology. The question is, did they use trigonometry, or an earlier, simpler system of ratios to achieve these results? Perhaps their simplicity was their greatest sophistication. We cannot discuss impossible structures without addressing the most controversial and popular theory, the ancient astronaut hypothesis. This theory suggests that the impossible feats of construction, the precision cuts at Puma Punku, the colossal lifting at Baalbek, are evidence of extraterrestrial visitation or intervention. Proponents argue that the advanced, complex nature of the structures and the too-perfect technology could not have been achieved by humans operating with copper chisels and wooden rollers. Therefore, the blueprints or the tools themselves must have been provided by a non-human intelligence. While compelling for its drama and widespread appeal, this hypothesis is largely dismissed by mainstream archaeology. It fails to provide testable evidence, and, perhaps most importantly, it diminishes the potential for human achievement. The strongest, though least glamorous, counter-argument is that the answers lie in sheer, magnificent human ingenuity. We often underestimate the power of collective effort, social organization, and focused problem-solving when applied over generations. The ancient builders may have simply developed ingenious, low-tech methods, lever systems, water locks, or specialized ramping techniques that were incredibly effective but didn't leave behind obvious archaeological evidence. The enduring lesson here is that our current inability to explain something doesn't automatically mean the answer is extraterrestrial or ultra-high tech. It often means we haven't yet found the full evidence of their cleverness. The genius was not in the lost machine, but in the minds of the people. So, which is it? Lost knowledge, cosmic guidance, or forgotten human brilliance? The structures stand silent, offering only geometric riddles and astronomical clues. We've seen the sheer impossibility of these ancient feats. But these structures are not just dusty relics. They are blueprints. They are silent professors, teaching lessons in efficiency, resilience, and sustainability that modern engineering is only now beginning to fully appreciate and replicate. The genius of the past continues to shape the future. Let's return to Sacsayhuaman in Peru. The builders there faced the ultimate challenge: construction in a highly volatile seismic zone. Their answer, the interlocking, irregular polygonal stonework, was not just aesthetic, it was fundamentally functional. This technique, which allows the stones to shift and move independently during an earthquake, is essentially an ancient version of a cutting-edge modern technology: base isolation. Modern structures in earthquake-prone areas often sit on systems of bearings and shock absorbers designed to decouple the building from the ground movement. The Incas achieved a similar effect, not with steel and rubber, but with meticulously cut, perfectly fitted stone. They solved the problem of seismic energy distribution over 500 years ago, demonstrating the mastery of passive structural defense that remains a gold standard. Modern civil engineers study these walls intensely, seeing in them the elegant, low-tech solutions to high-tech problems. The lessons continue in the materials science. If the geopolymer hypothesis for the Giza blocks is true, then the Egyptians possessed a recipe for manufacturing synthetic, durable stone with incredible energy efficiency. Today, industrial cement production is one of the largest emitters of carbon dioxide globally. Imagine the environmental and economic impact of rediscovering a lost geopolymer formula, a low-carbon, highly durable synthetic stone that could revolutionize infrastructure development around the world. The ancients solved a production problem that plagues us today, simply by understanding local chemistry and resources at a microscopic level. Finally, perhaps the most profound impact is the least tangible: the lesson of human capital and organizational structure. The sheer scale of Giza, the coordination required to move bluestones 140 miles for Stonehenge, or the collective precision needed to carve and place the H-blocks of Puma Punku, all demonstrate a mastery of project management and workforce organization that is truly staggering. They achieved perfection not through high-tech tools, but through absolute discipline, standardization, and the ability to unite a vast population behind a single colossal vision. These projects teach us that perceived limits are often just organizational failures. They highlight how observing these structures forces us to reconsider the perceived limitations of human capability in the past, and by extension, what we might be capable of achieving today with pure willpower, collective collaboration, and problem-solving skills focused on a common goal. The echoes of ancient ingenuity are not silent. They resonate in every engineering firm attempting to build earthquake-resistant structures, every material scientist seeking sustainable cement alternatives, and every project manager attempting to organize a complex, multi-year build. The impossible constructions remind us that we are simply standing on the shoulders of forgotten giants. But even with modern science borrowing their blueprints, a few crucial questions remain stubbornly unanswered. We started this journey by asking an impossible question. How did ancient civilizations achieve feats that challenge the very limits of modern engineering? We've seen the evidence: the 1,000-ton stones of Baalbek moved without wheels, the earthquake-defying precision of Sacsayhuaman, the astronomical perfection of Giza, and the interchangeable modular blocks of Puma Punku. We've analyzed the theories, from lost geopolymers and acoustic levitation to pure, relentless human ingenuity and organization. But despite centuries of research, millions of dollars invested in scientific exploration, and all the powerful tools of the 21st century, the full truth remains elusive. A few crucial questions continue to stand guard over the true knowledge. Did the ancients use a sophisticated system of simple machines we haven't properly identified, where the knowledge was passed down orally and simply perished with the populations? Or did they truly unlock a profound, forgotten law of physics that allowed them to conquer gravity and density? The structures stand silent, offering only riddles carved in stone. This is the enduring mystery, and it's why these ruins continue to inspire such awe. They are not just monuments to the dead, they are eternal challenges to the living. They force us to discard the perceived limitations of the past, and in doing so, make us question the limits we impose on ourselves today. If they could achieve such perfection with copper chisels and ropes, what is truly possible for us now? Think you know ancient history? Hopefully, your mind has been blown, your curiosity ignited, and your view of human capability radically expanded. The journey to decode the impossible never ends. It is an invitation to confront the sheer ingenuity of civilizations long past. You won't look at ancient ruins the same way again. Now we want to hear from you. What is your theory? Do you believe the answers lie in a forgotten technology, cosmic guidance, or simply the magnificent power of collective human genius? Share your thoughts and perspectives in the comments below. Let's keep this conversation going. Don't forget to like this video, Subscribe to our channel for more deep dives into history's greatest secrets. And join us next time as we continue to decode the world's enduring enigmas.